This video is going to be talking about the propulsions aspect of your space race project, what propulsion is, and how you guys are going to implement it in your rocket design. So what is propulsion? Well, propulsion is the act of pushing an object in a direction. Um, Things that use propulsion could include rockets, jet airliners, boat motors, basically anything that's going to propel an object in one direction. Anything that uses propulsion is going to be using a concept that we learned called Newton's third law. If you guys will remember, Newton's third law basically says that for every action, there's an equal and opposite reaction. So, and again, in the case of this skateboard, the action is the foot pushing on the ground, and the reaction is that the skateboard is sliding in the opposite direction. Okay? So let's think about this from a rocket standpoint. If you have a rocket, what would be the propulsion propelling that rocket into the air? So, if you look at this picture of a rocket taking off, you will notice that the rocket, as it's flying into the air, is producing a gas out behind it. Okay, so a rocket propulsion engine works by a combustion reaction that forces gas out of a small hole at the bottom of the rocket and then produces a lot of force to get that rocket off the ground. Okay, so again, rocket combustion engines are producing that propulsion force so that the rocket can overcome the force of gravity. Okay, so the force of gravity, again, like we talked about, is a force that is always pulling things towards the Earth's surface. It is an attractive force. Okay, so for us to get a rocket off the surface of the Earth, we need to have a force that is overcoming the force of gravity. Okay, now you got to remember the force of gravity is different for every single object. Okay, if you remember back to our gravity unit, the acceleration of all objects as we drop them are the same. However, the amount of force acting on each of those objects is not the same. You can think about trying to catch a bowling ball dropped off a building and trying to catch a tennis ball dropped off the building. One of them is going to hurt significantly more than the other. So again, in order to get your rocket off the ground, you're going to have to produce enough force to overcome the force of gravity. Okay, and we'll talk about how you will figure that out here in a second. Okay, so gravity is not the only other force at play in this. Okay, there will also be a friction force. Okay, so again, a friction force is another force that is going to be opposing any motion. Okay, and again, our rocket will be propelling itself off the ground and moving through the air. So if you had to guess where the friction would be coming from, it would be probably be coming from the air. Okay, and we call this drag. Right? So drag is basically an air friction force that is caused by little gas particles hitting our object and slowing it down in one direction. Okay, that would be opposing its movement upward and onward. Okay, and again, the bigger surface area that we have, the bigger friction force. Okay, and that still applies with air friction, aka drag. So what are all the forces involved? So not only are you having to overcome a gravitational force of the rocket's own mass, okay, you're also going to have to overcome an air friction force. Right? Now, we will not be putting your rockets into orbit. So at some point in time, your rocket will have to succumb to the force of gravity and air friction. Okay, but in order for this competition to work, we are trying to get it as high as we can. So you want to produce a propulsions option that will force your rocket into the air for as long as it can and hold off the forces of gravity and drag for as long as it can. Okay, so your rocket, obviously, you're not going to be able to use rocket fuel. If you try to buy rocket fuel, you will probably be put on some sort of TSA watch list. Okay, so here are some options that you might think about using. Okay, one option could be a slingshot. Okay, you could design some sort of slingshot contraption that will launch your rocket into the air. Okay, another one could be air powered. Okay, I think stomp rockets were well before your time, but the basic concept is you have a flexible container that you can stomp and force air out of that would then push air into your rocket body and then lift it off the ground. Another one that you guys could use could be a water pressure rocket. Okay, so the idea there is that you pressurize water inside of a chamber and then release that water, producing a thrust force. If you would like, you guys could also talk to me about using harmless chemical reaction like vinegar and baking soda to build up that pressure. Okay, but it must not include fire. Okay, we will not be using any sort of combustion reactions to be lifting our rockets off the ground. Because we're doing this outside and around the school building, it would be too much of a liability. Okay, it's one of the same reasons why in Johnson County you're not allowed to shoot bottle rockets off around 4th of July. Okay, so your requirements. Right, I'm going to need a free body diagram. Okay, I'm going to want to know all of the forces that are at play on your rocket. Okay, not only do I want a free body diagram, I want you to label each of the arrows with the corresponding forces. Okay, and I'd also like you to label them with the magnitude of the forces. Okay, which will lead me into my second requirement is your calculations. Okay, you need to have calculations to back up your claims for your rocket propulsion options. Okay, you need to be able to calculate what the force of gravity on your rocket would be. Okay, you need to be able to calculate what the friction force might be. Okay, that might take a little bit of research. You might have to look up what the coefficient of friction of air is. Okay, but you need to have your calculations to back up your rocket design. Okay, once you have those two done, you may pick a launch mechanism. Okay, this will be the fun part where you get to design the method in which you will lift your rocket off the ground. Okay, you can use any of those options. I am also open to other options if you have different ideas. Okay, however, for this part of the project, you must come to me for safety approval. Okay, I must approve of your rocket design. Okay, so if you have any other questions, you could just come find me in class. Otherwise, this is the end of the video. Good luck building.